next up, we will look at a rational function. The one I want to look at is number 16. So let's see, what is 16? I'll call it f of x. X over x squared minus 4. So we see that it is a rational function, polynomial over polynomial, and with that I probably expect to have some asymptotes, some x values where the function might not be defined. So step 2 will have a little bit more to it. I can, however, still find the x-intercept as when x is equal to 0, y is equal to 0 as well. So we can start putting some stuff on our graph to see how it eventually evolves and the shape becomes more obvious. Right now I don't have much. I have a y-intercept. So, next up, asymptotic behavior, where I want to see, are there any asymptotes? What are they? How does the graph behave? And so on. Well, for that, I'm looking at my function, and to see it more clearly, I might want to factor the denominator, difference of two squares, x plus 2, x minus 2. And then I can see that there are vertical asymptotes, not x, not y, but x equal to 2, x equal to negative 2. That is where the function is going to be undefined in the rational function case. That means vertical asymptotes. So I have these two dotted lines indicating the vertical asymptotes at 2 and at negative 2. Now, at this stage you might feel, I need to know what happens as the graph gets closer to these x values. You could, but because we know we're doing the full graphing steps, when we get to step 3, it's going to be clear what the behavior is. So right now, as I'm getting close to this vertical asymptote, the graph is going to go up or down. I don't want to spend any effort figuring out which way it's going to go when I don't really need to, because in step 3 it's going to come out very easily. So it's okay at this stage to not really know exactly, but I could make a table for the function to figure it out. Next up, horizontal asymptotes. Are there any horizontal asymptotes? Well, because it is a rational function, I know that the long-term behavior is determined by the ratio of the leading terms, which in this case, it's going to behave like 1 over x. Because the bottom has a higher degree polynomial, it will shrink down to 0. So my horizontal asymptote is the line y equal to 0. Now again, that is sitting right on the x-axis. I don't really care to figure out which way it approaches the horizontal asymptote. Step 3 is going to point that out very easily. So this is all I'm going to do in step 2. Now in step 3, I'm looking at increasing and decreasing behavior, where I need to find the derivative. So I'll look at this first version of the function and use the quotient rule. Quotient rule says bottom one squared, which is x squared minus 4, square that, and then the derivative of the top, let's do it like this, we can see them both, times the bottom minus the top times the derivative of the bottom. Let's extend my line. That is the quotient rule. Now I definitely want to clean this up. So let's clean up the numerator. Let's not skip too many steps. I have x squared minus 4 minus 2x squared over x squared minus 4 squared. Let's clean up the numerator a little more. I have, let's write it like this first. Let's just see it. Negative x squared minus 4. We can take out a negative 1, and then it becomes x squared plus 4 over x squared minus 4, everything squared. Now be careful, one has a plus, one has a minus. The sum of squares cannot be factored, but the difference can be factored. So I'll clean that up a little further by factoring it so that we can see how to get our critical points out. Difference of two squares, still x minus 2, but now everyone there gets a square. So this is going to be my version of the derivative that I may want to look at. So take care and make sure you can follow all these steps. Let's see how much space we have. We have lots of space. So I can say here my derivative is 0 and my derivative is undefined for certain x values. That is where my critical points will come from. Can my derivative function ever be 0? Well, in the case of having a numerator and a denominator, I look at the numerator. Can that ever equal 0? Well, you might want to write down the equation if you're not sure, and it's going to be where x squared plus 4 equals 0. But that means x squared is equal to negative 4, which can't happen. So, whether you write this down or not, whoopsie, there are no x values making the function 0. But there are some where the function is undefined. That is going to be when x is negative 2 as well as 2. So those are our potential critical points coming out. Whether or not they're actual critical points is kind of irrelevant. I list them on my function all the same. On my table, I mean, sorry. So we have a lot more in our table, but still just broken up into 2 pieces. On the left here, I will indicate all the pieces, negative 1, x squared plus 4, which I cannot factor. Maybe you can list every single piece. Let's maybe list these 2. Let's list them all. The simpler each piece, the easier it is. But you can definitely condense this table if you want to. This is the very detailed version. Adapt the table to your needs as you want. Negative 1 is always going to contribute a little negative. X squared plus 4 we've established up here can never be 0. It's always going to be positive. X plus 2 is 0 when x is negative 2. Same for this x plus 2. It is in the denominator, so it makes the function undefined, the derivative function. It's going to go from negative to positive, negative to positive. X minus 2 is 0 when x is 2. And it's also in the denominator, makes the derivative function undefined. It's also going to go negative to positive over its 0. So, all these by way of multiplication and division. How many negatives do I have for the first section? 1, 2, 3, 4, 5. So the answer will be negative. 1, 2, 3. So the answer will be negative. 1. So the answer will be negative. So if I look at my slope lines, it is going to be a downslope, and then bad things happen, and another downslope. Downslope, bad things happen, downslope, in the sense that there are no points. When I look at my original function, I can't plug in x equal to 2 or negative 2. So there are no y values. The function is undefined. So we'll say up here, there are no critical points. They are potentially critical because they come out of this list, out of these two checks, but they're not points to be called critical points. I can, however, sum it up by saying f is, it's all decreasing in this case. On the intervals, I have to break it up at negative 2 and 2 because it's not in the domain of the function. It's not defined there, so I can't include them. I can't just write negative infinity to infinity. That would not be right at all, because that implies that the function is defined everywhere, and it's not. I have to say negative infinity to negative 2, as well as negative 2 to 2, as well as 2 to infinity. I have to split them up like that. It does, however, give me my information. I have no critical points, which makes sense on the graph. I'm jumping over these asymptotes. Now have a look at these arrows. On the left section, going up to negative 2, I have everything's decreasing everywhere. So it cannot be this, because that implies an increasing trend. So I'll make my, what do I erase? Let me just find the eraser here. I think it's this button, yes. Can't be that one. And it can't be that one. I have to go down. I have to also go down from negative 2 to 2. Can't be this one, because that would be up. And it can't be that one, because that would be an increasing trend. So I have to go down throughout. Same over here. Cannot be this one. That would be going up. Can't be that one, because that would be going up in the trend, and it has to be this way, in some way. Please remember to click the like button if you enjoyed the video, and to subscribe if you want to be notified of more videos. Thank you.